In this video, we're going to talk about solving exponential equations and inequalities. So let's just go ahead and jump in by doing some problems. So we're going to start by solving 2 to the x power equals 8 to the third power. And the way I want to set up these problems is by doing a 2-column reasoning proof type of problem so that you see why we're doing exactly what we're doing. So in starting the problem, we want to go ahead and write down the original problem. So we write down the problem, and the reason is that it's the original equation. So what we're doing in this problem is we're trying to solve for our variable, our x variable. So if you can tell, it's in the exponent position, so it makes it a little bit more difficult to solve for. But our goal in this is going to be to solve the problem by creating the same base. We want the same number here as is here. And we're going to have to figure out a way to do that. So the first thing you want to ask yourselves is there a number that is going to have the same base that can be equal to 2 and that can be equal to 8? So it'll take some time to recognize this, but you'll recognize that we know that 8 is the same thing as 2 cubed. So we're going to rewrite 8 as 2 cubed. So we rewrote that 8 was the same thing as 2 cubed. And this is great because the base already here is the base 2. So we can just leave this side as is. So the reasoning is that we just rewrite 8 as 2 cubed. So if you notice, they both have the same base, which is what we wanted. So now that they have the same base, let's go ahead and simplify this side. So when we have a power to a power, we multiply the powers, and we are left with 2 to the 9th. Okay, so this is what we get. We get that that 2 to the x is 2 to the 9th. All we did was take the power to the power. That's our reasoning right there. So now that we have the same base, that's what we want, and everything else is simplified. So now that they have the same base, the property of equality for exponential functions, in which you're going to do in one of your other tiers, talks about when they have the same base, you can just get rid of the base and use the exponents and set them equal to each other. So really we can just write this as x equals 9 because they have the same base, and that was our goal, so that we could just write the exponents to be equal to each other. And in this case, the x is already alone, so we don't have to do any more steps, and we know that x equals 9. And again, the reason there is that we have the property of equality for exponential functions. Alright, so let's take a look at another example. We have the problem solve 9 to the 2x minus 1 equals 3 to the 6x power. Okay, so again, we're going to do this problem using a 2-column reasoning / proof style. So we write down the original problem, and the reason is it's the original equation. Alright, so we have this problem, and again, the first thing we want to look at is their bases. Okay, so we look at the base number, the big number, okay? And I want you to notice something about these numbers. You can ask yourself, okay, can we write them so that they have the same base, but maybe to a different power? So you'll learn to recognize this, but 9 can be written as 3 squared, right? So we have the base of 3, so that'll be in common. So let's go ahead and do that. So we would have 3 squared is the same thing as 9, right? And then you just put everything else with it. Equals, and then our base is already 3 over here, so I'm going to keep the 3 to the 6x power. And the reason is that we're rewriting 9 as 3 squared. Alright. So now that we have the bases as the same, let's go ahead and get rid of these parentheses because it looks kind of funny. So let's, when we have a power to a power, we multiply. So we have to remember in this case that this whole thing right here is a power. So we're going to have to multiply this 2 by the 2x and this 2 by the -1. So we're going to have to make sure and remember to do both of those things. And we would get 3 to the 4x minus 2 equals 3 to the 6x power. Reason again is it's a power of power. Beautiful. So we're working right along. It's looking pretty similar to the last one. And again, this is beautiful. We have the same base. So when we have the same base, what can we do? We can get rid of the bases, right? And we can just write the exponents equal to each other. So we can take the exponents. 4x minus 2 equals 6x. Awesome. And the reason there is, again, because of the property of equality for our exponential functions. And now this is just a 3-step equation. Okay, so in order to solve this, we need to put all the x's on one side. So I'm going to get rid of my 4x's on this side. I want them all to be on my left, sure. Okay, we get negative 2 equals 2x. That reason is because we subtracted 4x from both sides. And then to finish out the problem, we still don't have x by itself. So in order to get x by itself, we need to divide by 2. Divide by 2. And we're left with negative 1 is equal to x. And the reason there is we divided by 2. So we are left with negative 1 is equal to x. Alright, so let's jump to another example. And in this one, we're going to be talking about inequalities. So we're going to solve 16 to the 2x minus 3 is less than 8. So don't get freaked out about the less than, greater than, any of those symbols, because really we're going to basically do the same steps. They look very, very similar. So again, we're going to start with the original inequality when we set up our 2-column proof. Alright, step 1, we write down the original inequality. Awesome. Okay, again, in this case, we really want to have the same base. So we are looking for the same base. What number can we write with an exponent that is going to be equal to 16 and going to be equal to 8? So this one's a little bit more difficult. The other ones were a little more straightforward because we used one of the numbers that was already in there. So we have to think, okay, what number can we raise to a power, any power, that they're going to have in common? So if you think about this, we know that the number 2 can be raised to the 3rd power to get 8, and 2 can be raised to the 4th power to get 16. So 2 is the common base that we're going to end up using. So now we just need to rewrite them. So for 16, we're going to rewrite it as 2 to the 4th power, to the 2x minus 3, we just keep writing, is less than, we still need the same base, so we have to rewrite the 8 too, so is less than 2 to the 3rd power. Alright, the reason is that we rewrite 16 as 2 to the 4th and 8 as 2 to the 3rd. Alright, beautiful. So now we just need to go ahead and simplify this, get rid of our parentheses. So again, we're going to have to use the same tactic as before, where we have a power raised to a power, and this power happens to have 2 terms. So we have to make sure that we distribute to both pieces. So we're going to have to go here and here. Okay? So we're going to be left with 2 to the 8x, because 4 times 2x is 8x. And then minus 4 times 3, which is 12, is less than 2 to the 3rd. Beautiful. Reason being, we got a power of a power. Now we're just where we want it to be because our bases are the same. So what can we do when our bases are the same? We can get rid of our bases and just write our exponents, okay, based on the rule we know, or we're going to know very soon. So we can get rid of the base, and we're just left with 8x minus 12 is less than 3. And this reason holds true for properties of inequalities as well as just equations. So we can do this because of this reason right here. Now this is just a 2-step inequality that we have to solve just like we would if it was an equal sign in there. Okay, so what we need to do is we need to get the x's by themselves, correct? So we need to get rid of this 12 right here. And how do we undo a minus 12? Well, we add 12. So we add 12 to both sides. We're left with 8x is less than 15. Reason being, we added 12 to both sides. Awesome. Now we just need, x is still not alone, so we have to get it alone. So we have to get rid of that 8. How do we get rid of that 8? We divide by 8, and we divide by 8, and we are left with x is less than 15 over 8, because we cannot make that a whole number, and I like fractions, so we're going to leave it like that. And like I said, the reason is we divided both sides by 8, because we did that right there to get this right there. So that's our answer, and it didn't look any different than if we had an equation. It just happened to have an inequality sign, so we're left with this as our answer. Now I want you to keep in mind, if you go back through all the problems that we have done today, you are going to see a very prominent pattern, that this is kind of what we're going to do basically the whole time, minus some of these specifics, but really we're doing the same thing almost the whole time. Okay, when we're able to rewrite the bases to have the same base, it becomes a piece of cake. And we're going to learn later how to do it if we're not able to, but everything that you're going to be doing in these tiers, you're able to rewrite as the same base. So you can follow this sort of pattern for just about everything you're doing, and it's going to work out pretty well. And good luck.